put yourselves positioned for a boundless disaster of exceptional extents underneath the purple Goliath CB changed on the edge of our structure. It is passing on troubling messages through the universe using the James Webb Space Telescope. Cosmologists have decided something fundamentally agitating about this critical huge body. As astrophysicist Brian Cox offers a grave affirmation, the inquiry-weaving machines we say we are on the slant of seeing an unfortunate God impact influence that may forever change the night sky. To the degree that we can be occupied, we ought to dive into the astounding woven craftsmanship of the universe where stars are thought about, live, and pass on in beautiful plans. One superstar has really gotten the creative mind and type of cosmologists and the public the same. This notable star is a red monster of gigantic extents and age. Coordinated clearly inside the amazing body, its undeniable tan variety and intricacy have for a really long time been a wellspring of interest. Later advancements have supported interest in this great monster, as we find the probability of an approaching awesome event. In the current example of this star, paying little heed to what these activities may suggest, we may be on the cusp of seeing a perpetual presentation of unbelievable scale. More than our child, it is a sublime behemoth. Its full enormous size is almost past human ability to get a handle on. Imagine a star so enormous that if it were to displace our Sun, its surface would extend past the circle of Mars, overwhelming Mercury, Venus, Earth, and Mars in its imminent hug. This isn't simply an uncommon presentation of the star's genuine characteristics, but in addition tends to its stage in the brilliant life cycle. As a red very Goliath, it is in the nightfall of its presence, a phase portrayed by expansion and cooling following a lifetime spent combining hydrogen into helium in its center. However, what might be said about the age of this megastar, estimated to be around 8.8 to 8.5 million years old? It is moderately youthful in human terms, yet old concerning heavenly lifetimes. It is in the red Goliath stage, a consequence of millions of long periods of heavenly advancement set apart by significant changes and cycles that have changed it from a hot blue star to the red monster we see today. The current case of stars like this one is a story of improvement driven by the consistent powers of atomic combination and gravity. Its sketchy bronze variety is another sign of its constant stage. The red tone is a consequence of its somewhat cooler surface temperature contrasted with different stars like our Sun. While the Sun's surface temperature is around 5,500 K, this star's cooler surface registers temperatures around 3,500 Kelvin. This cooler temperature gives the star a red appearance. However, this tone isn't simply a visual element. It gives scraps of data about the star's condition and the cycles occurring inside, adding to the star's character. What further enhances its identity is its variable nature. Old Roman and Chinese works recommended that about 1,000 years ago, it became yellow. It was in the 900 years that Arabic cosmologists initially portrayed it as red. This variety shift over human history isn't just a detail in the annals of cosmology, but also a sign of the star's tremendous changes. The variable brilliance of the star is another spellbinding viewpoint. It is a semi-standard variable star, meaning its light periodically fluctuates. This changeability is a grandiose dance of brilliance that has captivated stargazers and skywatchers for hundreds of years. Typically, the star undergoes a multi-day cycle alongside a longer cycle that stretches around 5 years. These cycles were recorded as far back as 1836 by Sir John Herschel and likely even earlier in local oral practices. What makes this star mysterious isn't simply its changing brilliance but its unpredictability. Unlike many stars that follow predictable patterns, it inconsistently strays from its rhythmic darkening and lighting up, illustrating unpredictable and less understood processes happening inside its structure. Recent discoveries have caught the attention of cosmologists and stargazers universally, with a captivating change in its appearance. An event known as the extraordinary darkening occurred in late 2019 when the red very Goliath, one of the most striking stars in the night sky, began to diminish mysteriously. The star's diminishing was pronounced to such an extent that it began losing its shine at a significant rate, reaching its lowest brightness in February 2020. Normally visible to the unaided eye, even in light-polluted areas, the star became observably fainter, a change detectable even to amateur spectators. However, there is one challenge with attempting to figure out the events of this star. The the time oddity. When we notice a star like this, we are not seeing it as it exists in the present but as it was in the past due to the time it takes for light to travel to us. In this star's case, at around 725 light-years away, the light we see today left the star almost 7 centuries ago. This defer makes it challenging to predict and make sense of unexpected changes in a star's behavior, as we are essentially looking into its past. The extraordinary darkening event filled in as a delineation of the innate hardships of cosmic observations and the limitations of our insight while managing tremendous cosmic scales and the time peculiarities they present. This was firmly seen by Andrea Dupree, head of the Center for Astronomy at Harvard and Smithsonian, and her team. They used Hubble to dissect the star as part of a 3-year study to examine variations in its outer climate. These observations provided outstanding insights into the dynamics of a variable star like this one, which regularly expands and contracts, causing changes in brilliance. Hubble's aversion to light allowed the scientists to examine the layers above the star's surface, which were warmed essentially by the star's wild convection cells. Further investigation of the Hubble spectra taken at specific points during 2019 and 2020 revealed the movement of material in the star's outer climate, particularly the spectra focused on magnesium lines, which are typical for celestial conditions. These observations showed material moving at speeds of around 200,000 miles per hour from the star's surface into its outer climate. This hot, dense material eventually extended thousands of miles from the star and formed a cloud that caused the star's diminishing. Dupree and her team estimated that twice the normal amount of material from the star's southern hemisphere was lost over the 3 months of the eruption. This mass loss was significant, especially since, like all stars, this one regularly loses mass but at a much higher rate than our Sun. The size of this mass launch and the subsequent dimming sparked conversations among cosmologists about whether this event could be a forerunner to an enormous blast. The vicinity of the star, around 725 light-years from Earth, adds to the interest as such a blast would be visible from Earth and provide a great opportunity to witness a grandiose event very close. However, this still has yet to be addressed conclusively. What does this event mean for our understanding of the universe and its celestial phenomena? Could this be a sign of a supernova, a catastrophic event that marks the explosive death of a massive star? Supernovae are among the most powerful events in the universe, releasing immense amounts of energy and synthesizing elements crucial for life, such as oxygen and iron. If this red supergiant were to undergo a supernova event, it would likely briefly outshine an entire galaxy and become visible across vast distances, potentially even during daylight on Earth. The study of such events not only contributes to our understanding of stellar evolution, but also provides insights into the composition and dynamics of the universe. Supernovae are essential for dispersing heavy elements created in stars throughout space, enriching future generations of stars and planetary systems. For astronomers and astrophysicists, studying stars like this red supergiant offers a window into the final stages of stellar life cycles and the cataclysmic events that shape galaxies. By observing changes in its brightness, spectral emissions, and mass loss, researchers can refine models of stellar evolution and better predict the behaviors of similar stars in the cosmos. Moreover, events like the extraordinary darkening of the star highlight the importance of long-term observational studies and the capabilities of advanced telescopes like the Hubble Space Telescope. These instruments enable scientists to capture detailed data and analyze complex processes occurring millions of light-years away, providing unprecedented insights into the workings of the universe. As our understanding of stars and galaxies continues to evolve, each new observation and discovery adds to the tapestry of knowledge about our place in the cosmos. The study of cosmic phenomena like the red supergiant and its potential supernova event not only fascinates us with its grandeur, but also deepens our appreciation for the intricate mechanisms governing the universe's vast expanse. In conclusion, while the future behavior of this red supergiant remains uncertain, its recent extraordinary dimming serves as a poignant reminder of the dynamic and ever-changing nature of the cosmos. By continuing to explore and study such celestial events, scientists are poised to uncover more of the universe's secrets and expand humanity's collective understanding of the cosmos. The text provided is a detailed exploration of a red supergiant star and the recent extraordinary dimming event observed in late 2019 to early 2020. The star in question is described as a red supergiant, which is a massive star nearing the end of its life cycle. It has a significant size and age, making it a focal point for astronomers due to its unique characteristics. Red supergiants are stars that have evolved from being hot blue stars to cooler, red-colored stars as they age. This change in color is due to their lower surface temperature compared to younger stars like our Sun. This particular red supergiant is noted for its variability in brightness. It undergoes periodic changes in its luminosity, which can be observed over short-term cycles, multi-day, and longer cycles around 5 years. This variability is intriguing to scientists and has been observed and documented for centuries. The most significant recent observation was the extraordinary dimming event that occurred from late 2019 to early 2020. During this period, the star's brightness decreased dramatically, becoming notably fainter even to amateur astronomers observing it from Earth. Studying events like the extraordinary dimming poses challenges due to the vast distances involved. The star is located approximately 725 light-years away, meaning that the light we observe today left the star around 7 centuries ago. This time delay complicates real-time understanding of events occurring in the star's present. Researchers, including Andrea Dupree and her team, used the Hubble Space Telescope to closely analyze the star during and after the dimming event. They observed significant changes in the star's outer climate, including the movement of material at high speeds and the formation of a dust cloud that contributed to the dimming. The dimming event sparked discussions among scientists about whether it could be a precursor to a supernova, a catastrophic explosion marking the end of a massive star's life. Supernovae are crucial for dispersing heavy elements throughout space, which are essential for the formation of new stars and planets. The ongoing study of this red supergiant provides valuable insights into the final stages of stellar evolution and the dynamic processes occurring within stars as they approach the end of their lives. This research contributes to refining models of stellar evolution and understanding the broader dynamics of the universe. Advanced telescopes like the Hubble Space Telescope and the James Webb Space Telescope play crucial roles in studying distant stars and celestial phenomena. They enable scientists to capture detailed data and analyze complex processes millions of light-years away, enhancing our understanding of the cosmos. In essence, the text provides a comprehensive overview of a specific red supergiant star, highlighting its unique characteristics, recent observable events, and the scientific implications of studying such phenomena. It underscores how these studies contribute to expanding humanity's knowledge of the universe and our place within it. The text provided explores a red supergiant star and its recent extraordinary dimming event observed from late 2019 to early 2020. Red supergiants are massive stars that have progressed beyond their hydrogen-burning phase and are nearing the end of their life cycles. These stars are known for their immense size, often hundreds to thousands of times larger than our Sun, and their cooler surface temperatures, which give them a distinct red coloration. A notable characteristic of red supergiants is their variability in brightness. This variability arises from pulsations in their outer layers and changes in the distribution of hot spots on their surfaces. Studying these brightness variations over time provides astronomers with insights into the internal dynamics of these stars, such as convection cycles and mass loss rates. The periodicity of these variations, ranging from days to years, offers clues about the star's physical state and evolutionary stage. The extraordinary dimming event observed in late 2019 drew significant attention from the astronomical community due to its sudden and substantial impact on the star's brightness. Detailed observations using telescopes like the Hubble Space Telescope revealed that the dimming was likely caused by the formation of a large dust cloud in the star's outer atmosphere. This dust cloud partially obscured the star's light as seen from Earth, resulting in a noticeable decrease in its apparent brightness. Observing such events poses challenges due to the vast distances involved. The star in question is located approximately 725 light-years away, meaning that the light observed today left the star over 7 centuries ago. This time delay complicates real-time understanding of dynamic events occurring in the star's atmosphere and outer layers. Despite these challenges, advances in observational technologies, such as high-resolution imaging and spectroscopy from space-based telescopes, have enabled astronomers to gather detailed data and analyze the complex dynamics of stars like this red supergiant. Scientific investigations into the dimming event have been extensive, with researchers led by Andrea Dupree using the Hubble Space Telescope to monitor the star before, during, and after the dimming event. Their observations provided critical insights into the mechanisms driving the dimming, including mass loss and dust formation processes in the star's outer atmosphere. These findings contribute to refining models of stellar evolution and predicting future behaviors of similar stars in the cosmos. The study of this red supergiant and its dimming event holds significant astrophysical importance. It deepens our understanding of the final stages of stellar evolution, including the processes leading up to supernova explosions. Supernovae are believed to be the ultimate fate of red supergiants like this star, playing crucial roles in dispersing heavy elements forged in the star's core throughout space. These elements are essential for the formation of new stars, planets, and potentially life-supporting systems in the universe. By studying the variability and sudden changes in stars like this red supergiant, astronomers can refine their models of stellar dynamics and better predict the cosmic events that shape our galactic environment. The ongoing research underscores the role of advanced telescopes and observational techniques in unraveling the mysteries of stellar evolution and cosmic phenomena, contributing to humanity's broader understanding of our place in the cosmos.